So hello guys, and today I want to start with a small series of tutorials that are gonna be showing off the workflow between Naiad and Max. So we're gonna end up with something that looks like this eventually. Show you the simulation. Now of course it's a very low res simulation, but I don't have the patience to run a long stuff on my home computer, which is pretty flimsy. So the idea is to just show you how the whole thing works from Max to Naiad and then to Max again. And we're gonna start with the really basic stuff, and I want to make a series of short videos. So we're gonna start with the basic stuff, and then once we have the basic thing nailed down, then we are just gonna add here and there a bit more advanced, like interesting elements. But I want to make sure that everything really basic is covered first, and then we can progress to the interesting stuff. So that's my scene eventually, and I'm gonna close this down. I'm gonna start from the beginning. So the first thing is how I set up my project. So this is the main folder of the Max Naiad project. So you're gonna need a subfolder for the cache for EMPs, which is the Naiad cache, the OBJs, which is the geometry that you send from Max, and if you send geometry from Naiad to Max. PRT is your PRT caches. TPS I just have in my template because of twin particles caches that I use. Have a compound folder for like stuff that goes out of Nuke, render out folder for stuff that goes out of Max, and V-Ray renderings, scenes. You have Max scenes, Naiad scenes, Nuke scenes, and of course here you can have like textures, inputs, and all this kind of stuff. So I'm just gonna start by opening my geometry scene. So the way we're gonna do it is that we're gonna get this basic geometry from Max here, send it to Naiad, and then we're gonna do the simulation in Naiad. Just make some basic thing, really nothing fancy, but covering the solid basic stuff. Then we are gonna convert the cache from Naiad into PRT format, and we're gonna send it to Max, and we're gonna mesh it up with Frost. And then in next videos we're gonna do stuff like start adding magma flows to it and do interesting things with the shading based on the data in the channels that you can get from that. So gradually, as I'm exploring Naiad in the moment also, so it is going to be a gradual, ongoing thing, more than something that I have planned for now. So it is, freestyle exploration thing. Okay, so this is my geometry in Max. That's how it looks like. I just wanted to have a basic shape that I can, splash some liquid onto. Now the important stuff here is, let me just see. You see, I have two layers. So this is the first one that I actually used to model the stuff. This is the scale that I modeled it into, and if I go to customize unit setup, you're going to see it. My system units are well, in this case inches. I usually work in centimeters system units, and then if I select this guy, you can see for these things the measure utility is important. Just because Naiad as a simulation tool is very sensitive to scale, so you really need to take care that your units are the right size, that your objects are the right size, and so on and so on. So in Naiad, 1 unit is 1 meter, which means that when I do my usual procedure of doing stuff in centimeters in Max, I need to take care that I rescale my scene. So from the centimeter system units, I go into meter system units, which means I have to pretty much scale it down 100 times. And the next issue is that Naiad releases faster with smaller stuff when these things are smaller scale. Of course, this reflects on the feeling of scale that you have. So for the quick tests, I would go small scale. Then for the stuff that you need to look big scale, you're gonna upscale. But it's good that you can easily rescale stuff here. So in the measure, you see your dimensions here, so which is a good guide of pretty much how big the thing is. And then you can use the scale world units. So usually what I do is I just copy like my assets and stuff. And you can use the scale world units to scale it down. So this is the centimeters to meters accurate conversion. 0.01, and if I send this to a new layer and I go to this previous stuff, you can see there I have something which, if I go to measure again, it's going to be like 12, which means it's still a big thing, it's like 12 meters big, but if I got this guy, I scale this down even more, so this is like 3 by 3 by 1.5, this should be fine. And you see that I have attached everything together in one single object. And then what I do is I need to send the object to Naiad. Now this is still not really a finished thing. First, because Naiad has some problems importing it. Then there is no really a Naiad button, just like what you can do in Houdini, for example, that there is a tool which writes directly the Naiad format EMP cache the geometry in that format straight out of the application, out of Houdini for Max. The thing is still in alpha version, so it's still not finished, and instead you send it as OBJ format. So you can just go in here and just say export selected, or I have just made it a button here. So you go to the folder of the project, go to cache, obj, and you choose the obj. So this one is called piece. You can just make a template. And this is the obj export, because as I said, Naiad has obj input. So here the important thing is to unclick the materials. Don't really materials, but the really important thing is that you flip the y-axis. You can also do it in Naiad, like you can rotate, but it's easier if you do it here. Then you can just click export. There is a really nice script by Ruben Meyer on ScriptSpot that you can use to export a sequence of objs. But in my experience, at least here, Naiad doesn't read them well. There's a problem reading them, so setting animation is still a bit of an open issue. It's going to be solved very soon, I think. So then, when I have my thing exported from here, I can go to Naiad. And like this is an empty Naiad scene, I can save it down. Just here something to be working from. Here, scenes, Naiad. So let's just name it. Okay, so let's just build really a very fundamental, like basic Naiad scene. So what do we need? We need the mesh read. This is just for like reading in the mesh, and I'm not gonna go into really too much detail about how to do Naiad stuff, just because first there are a couple of I think even 3 or 4 videos out there already that show really this basic stuff. There is this nice help here that you can see, and there's some nice sample scenes. And second, I think it's just more useful that we just go through. So mesh read is gonna help us read the thing that we just exported. So let's go. Shitty thing is that I can't use my folder view in this dialog. So I can just use it here and then copy paste. Okay, so this is my template object. Now the thing is, but I'm gonna show actually this later. Here with the numbers of frames. So now I have my mesh read here. I don't see it. That's because Naiad requires a separate node to be able to visualize the mesh. It's called the mesh scope. And when I turn it on with this button here, you can see that I have it in my viewport already. So this is my mesh. Then I will need, as you saw here, I'm just dropping some liquid from like a volume there on the top. So for this I just use a sphere volume. This is the sphere volume here. I think this was like 0.5. You can just select it and move it above. Probably it was even less. Just want to make it so it overlaps a bit with this stuff. Okay, so now, as I said, there's enough really basic tutorials out there, but just to mention briefly, the mesh is a thing which is contained for Naiad of triangles, and the volume is a thing which is made of voxels. So since it internally works with voxels, it needs to convert the mesh to voxel to be able to do anything with it. So this means I need to put in another node, mesh volume. So this converts the polygonal mesh to volume, and then I need something to contain my particles. So this is the particle liquid. Actually, see body. Yeah, it was. Yeah. So this is the body particles, which means it is going to be the container for our liquid particles. So it gets initialized with all these specific liquid specific parameters here that you're gonna touch up at some point. So these are the particles that are going to be forming the liquid, and then I need to emit particles in there. So I need to go to emit. This is the liquid emit distance. So I need to connect the body so it knows like the particles that it generates here, it puts in this body, in this container. And then it needs a distance field, which means that I have this volume here, and I need the description of the volume that I have to put in there. So the volume itself is again just a container like the particles, and this container contains a field, which is this grid that is filled up with values, and the distance field here that it requires is just a field in which in every cell you get recorded the distance of it's a vector, like the distance of this cell to the surface. So it needs this to emit, just because, as I said, as I told you, it's doing everything with volume, like grid representations. So I need to get that field from this container and give it to this node. So let's see, this field export. And I need the distance field. It's stuff that you start doing by heart, or you just copy paste. Sorry, or you just copy paste. It's gonna make sense in a couple of minutes. So Then in order to at least like step through the simulation, like do a single simulate a single frame, I need terminal node, which is just the thing which Naiad starts stepping from, the thing at the end of the simulation. So I have different types of terminals, and I'm going to use the EMP terminal. Usually do. So this means that the result of the simulation, when it gets to the terminal here, gets recorded to an EMP, which is like the Naiad native format cache. And I need to specify here cache. So let's see. Need to go to EMP folder. Have a 10. We're gonna make another 10. Let's put it there. So here I need to specify the name of the file, and Naiad is still not doing the incrementation like the frame numbers automatically, so you need to put the hash symbol here, which is what it uses for replacing the frame numbers with. So this is the terminal. Now I can actually hit F3, which is, you can see here, step frame. Down here, you can see the hint. So step frame means solve one frame. So let's see how it's gonna go. Just looking up for licenses and stuff. I have, I think, 1 more week only on the license, but so once it steps through a frame, then you can start seeing stuff there in the middle. So here you see a blue thingy, which means particle body, I think, or like particle liquid body. So you can click on this and you can see different stuff inside that body. So you can see the different shapes, which are again containers. And each of these, like you saw, UC field, each of these has different channels. So a channel is like the low level data that you can get to. So this is a container, and shape is also a container, and then these contain the data. It is nicely explained in the documentation you have to do. So then I don't see any particles yet, so I need to put in the particle scope. So turn this on. And now, just okay. Now you can see I have some particles there, which is cool. I have, progress. So then what we need to do is to let's drop them down for this acceleration node. Just your force that you give it a vector for direction. See, up down 1.8 realistic value. I'll turn off the arrow, and I'm going to need the dynamics node, which is the actual liquid solver, and I'm going to need the join because I want to join in my collision volume somewhere in that flow. So let's see, I'm going to join first, and then I'm going to add the dynamics. So this is just the flow so far, then the other stuff comes in, with the join node, and then the dynamics. And I also think I will need to kill the particles there when they hit below the cup or whatever. So there is a particle kill plane, I think. Okay, so this is quite straightforward. The plane, just drop it below and turn it off. And I want to kill below the plane. Okay, so let's see. I hit F2 to reset, and I hit F6 to just start stepping forward in time. Meaning start simulating. So let's see how it works. and you immediately see, it works, it's cool, it's nice. But you can see that I have, like here, it doesn't really work, it's not interacting correctly with the walls, it's pretty much leaking from the bottom of the teapot. So I will need to go into the mesh volume, which is the representation of the volumetric representation of the mesh, and I'm going to do some stuff to make the whole thing easier for Naiad to just get. So let's see. I have thickening radius. Now this is very nice. So if I now increase and step again, by the way, you can see here it says this node is yellow, which means a warning, which means it's still gonna simulate, but it's gonna warn you. So it says cannot sweep channel, no such channel void. So if you click here, and I go to channel sweeping, it says can sweep channel. So channel sweeping is just something that Naiad is doing. It is getting, let's see here, from the body, from the pointer shape, which is pretty much the container for your vertices. You see that it has channel position and normal. And here in mesh volume, it says point dot velocity, which means the velocity channel in the point shape. And it doesn't really have a velocity channel. So it's trying to get a channel from the velocity and put it on the field, because you can see here, after the mesh volume, I have a shape field, velocity and distance. So if I go to velocity, you see this one is empty here. And I can just delete this for now, because I'm not really going to use it. So it's not going to try to sweep it. And it's just not giving this one. And we're going to revisit this later, because we can make some use from this. So now let's see if when I increase the thickening, I have a better result. Just because now Naiad added some voxels on the edges, so it can easier, it can make a more solid volumetric representation here, like voxel representation of the shape here, which is good. It's going to offset the liquid from the surface and the diffusion points. In a lot of cases, this is completely wrong. So here's stuff going on in simulating. Of course, when you do it for real, you're gonna separate this stuff and you're gonna be applying different thickenings to different objects and so on. But we are in for a tutorial here. Going with the clip box, which is the box on the particles, and I'm gonna remove the voxel shadow from the object, which is something useful, but I just don't want to hit there. It is just showing you what the resolution is of stuff. This is quite here. So now I can see stuff without obstruction. Actually, I'm going to remove the voxel shadow here also. Just have our particles. So this is alright, I guess. But this thing is a bit boring. And if you look at my thing here, I had this kind of stuff happening on the source. Not that it's really fine or anything, but I just want to put in this stuff in here because I think it gets into the basics. So what I did is I just got a field noise and I put that into the mask here, hemisphere mask. So if I increase contrast to like let's say 3 and make it smooth. If I unknow this again, see this shape gets cut out a bit. Often this is a good way to randomize, get some variation into your shape. And the cool thing is that you can also multiply this, but that's something we're going to get into later. Then the next thing is resolution-wise. I can go here. I can say, change the master voxel scale size, which is the global resolution. Like every voxel resolution that you have anywhere gets multiplied by this. Like this one, you see this one has a voxel scale, and then this one has a voxel scale. These are local parameters, and here. Yeah, it's here. These are local parameters, and these ones are global. You also have tile size, which is just the boxes that that Naiad allocates around there and calculates in each grid. This is something local, not the allocate only. The thing is, I don't mind this resolution. It's very low resolution, but whatever. But I just want a bit more particles. And then that's the cool thing about moving particles through a grid is that you can move more or less particles independent on the resolution of the grid. You can get nicer results with more particles even through a smaller resolution grid. So let's just make them a bit more. And I have interior and surface, and it just tells you what is considered surface, like this number of voxels, like this thick shell of voxels on the surface is considered surface, and you can make them a bit, put more particles on there if you wish to. So if I now simulate again, you'll see that my particle cloud is not much denser. And it's alright, Put some stuff happening. So I think it's cool because I have enough opportunity to show you, to just be able to see some stuff. You can see here also looking here. I would just drop the resolution a bit. Universal expensive solution for solving all your, leaking or any kind of tricky problems. Of course, it's gonna get more detailed also, which is fun. Still, it's still gonna be only a couple of minutes, even on a very slow machine here. One thing is that, speaking of slow machine, if I go there in my task manager, because actually I have right now all, small number of cores, but all are full. But Naiad has here this thread, which is pretty much making it easier for itself to do stuff on a certain amount of threads. It's just internal optimization, and it's smart for you to put this on the number of cores that you have. So I have stopped it, but I can just continue. And another interesting thing to know is that actually, if you run the simulation in the command line mode, it's going to be much faster. It's going to free up your computer to do other stuff. So obviously, we have some nice flash in here, like a pool down there. It's alright. I really wanted to go without editing, but I guess this would become quite pretty much. Actually, I think we don't need all the whole edge. Yeah, why not just this is a nice frame anyway. So, alright, we have these 57 frames now simulated. This was our Naiad sim. So this is pretty much a thing that you're going to see in most, or if not in all your Naiad sims. These are the really basic things. It's nice to have them out of the way. And the most important thing is just figure out how Naiad works and start thinking in its way. For me, it was very helpful talking to people and reading the manuals. It has a nice getting started, and the help view is great. You can just select a node and do it. But the help file, which explains like what the philosophy is very important. You should really go in. And then that's it for our scene. So we have this thing simulated here, okay? But now the result of our simulation is an EMP file. And we need to convert this EMP file to PRTs just to get into Max. So I'm gonna make another scene. Just a new graph. Okay. And then I'm gonna have here EMP read. So EMP read is just opening an EMP. And let's see where our EMPs were. Yeah, just here. Okay, click here, and now if I just leave it like this, Naiad is only gonna read that 7 frames. So I just set to replace this here. I can get a scope. And you're gonna see that I have all my particles loaded up until a certain frame, of course, that we simulated to. Okay, and usually I didn't have get this here, but usually, when the particle number becomes a bit bigger, you're getting sometimes on a cheaper video card like mine here, you could be getting some artifacts like tiles missing or particles appearing at random places. This is a GPU issue, video card problem, visualization glitch. You shouldn't worry in the simulation eventually, all the particles are alright. So I have the MP read there, and I also need actually body out. How is it called? Body right. Yeah, so. So body right is kind of a general exporter. So since it's in a live stack mode, I think there is like a green thing here. Even when I connected them, some bodies appeared over here. So you can see here I have the field shape, and but this is the green square, which is the field, and then this is the blue and white circle, which is the particle liquid body, and here I can see I have shape field, shape particle. Around the data channels. So in the body right, I need to go here and I have to say I should specify a body for the PRT output, because I have the particle liquid and the temp volume, and the temp volume is actually the rigid body height that I had. So I'm just going to choose particle liquid because I only want to export the PRTs to frost, the particles to PRT. So I specify this, and I have to choose the PRT format here. In the output path, I can just go to PRT. I'm going to make MP2. And here you just choose a folder. You don't item in. Naiad is going to item in the body and so on. So there, I need to turn this thing again, I think. And I can reset with F2, and I can step with F6. And actually, as far as I remember, we had frame 57, so I can just tell it to step into frame 57. Let's see. And this scene is only going to be practically converting the EMP to PRTs. And I think it's a good idea to just cache your stuff to EMPs just because it has all data. It is a nice base for other simulations that you're going to be doing. Again, stuff that you're going to be looking at later. So this is pretty much done. Okay, there was this one weird frame here. I think it was just something that I stopped and I left on the previous simulation. Shouldn't be a big deal. So now we have the EMP there, the PRT there. So now I can just save this to scenes, and this is going to be my EMP to PRT. So this is just going to be a generic sim that every time you can open and replace the things here and just get a conversion. So if I open my Max now, again, this is my geometry scene. Let's just make a PRT loader. I'm creating this stuff usually with active type, but if you don't have it, you can just go to create menu, and Capitol, and you have PRT loader. So PRT loader is the path. This is our temp2. It's automatically going to set itself to the right range, but then you can see that I first have the scale issue, so I need to scale it up. So I'm going to scale up 100 times. So this is the right, the correct way if you want to keep your the stuff that was in centimeters and so on. So I just this here, and then obviously my icon became a bit too big, so icon is going to go down. Where is it? Okay. So this is here. Now I'm going to place the CITs at 0. So I now need to tell it to use node transform. Okay, done. Use it, and then that's why it scales basically. But then I need to rotate it on the x-axis. So go here, 90 degrees on the x, which is going to make it in the right place. I think that's it. And yeah, first M particles don't really work just because of the way they are written into the file. Maybe F particles will be better. Okay, so now you see that once I rotate it on the x-axis, I have something which works. Let me see. I'll set my PRT loader to PRT scene. Layer, I mean, sorry. And then the stuff which got scaled, this guy here, I just have scaled wrongly. Obviously, when I was sending it there, let's see. Actually, I need to scale this guy also 100 times, and obviously I shouldn't have scaled only the PRT loader. Okay, so this is our simulation. You can see now it really works. Particles are where they should be. Everything is sweet. Okay, so I have now the PRT loader here, and then usually make another layer. Then I can just drop in my frost again, either with active type. I really recommend this to you, or with the menu, which takes a little more time. Actually, I don't even know where it is. Just hit menu, use it. It's in team box, and there is frost. Okay, there is a frost icon, and frost just needs a particle object, which is this guy. And usually what you can do is you can tell it to use render particles, and then you can just hide the PRTs. So otherwise it's going to try to use the viewport, and the viewport is going to hit on something like frost is extremely awesome, like the speed is insane. So you can see I kind of like almost scrap here in the viewport exposed. So let's see. Then you go adjust your particle size. You change to the nice meshing type. Should be some one, and then you increase probably the guess. Just because we have too few particles here, it's we can cheat not cheat, help mostly. Okay, so like the report color is chocolatey sweet. Yeah, I guess trimming is gonna get rid of particles on the outskirts. We're gonna do a bit more of this, smart way in one of the next videos. But I guess for now, we should know about it. And now, the last thing I have to do is to put in my material. So the whole shading phase, actually, is already set up in my other scene, and I'm just gonna open this one because creating lights and stuff is really important. And you can see one thing here. It says that it has a problem because on 0 there is no particles. So usually I just tell it to, because I just tell it to start from frame 1. Actually, you can either, like make your scene here start from frame 1, you can tell the PRT loader to start from 1 to 100, and then it's just gonna hold the last frame. Actually, it's gonna just read until frame 57. You can see here it complains that these ones don't exist. It should be, if I tell it to hold frame 57, then it should be alright, just because it's gonna hold the last frame. Okay, it works. Sweet. Okay, so now for the shading stuff, let's get to open that previous scene that I had. Yeah. Okay, I think it was this one. So here, here's some stuff that actually I'm going to show in the next video on the PRT loader. Just delete this stuff. Just leave the PRT loader here. Let's see first. Is that right? I hide the PRT loader, and this was my previous simulation. So, first thing that I did is to put a relax on top of frost, so you can see what the difference is. A relax makes these like bubbly, grainy shapes smoothened out. Sometimes you could need it, sometimes you could not. My experience that you need in the slower, calmer situations, and you don't need it in the faster, when you need more turbulent mesh. In this case, I guess it's fine to use. Just a cool thing you can put it on top. And then the material is a very easy thing. So the whole thing is a VI setup. Material is just something with diffuse, reflecting a lot, completely. I'm not a shading guy. I bet this is not a really good material. It's very basic. Just was trying to see what it will take to get a nice water, and it turns out it's really easy. And we're going to be doing some more interesting stuff in the next videos on like blending materials based on gels from Naiad, stuff like that, which is going to be interesting. And the only cool thing is this really nice map that I got for free from the internet, from CG Skies, I think. It's really cool, thank you guys. And it takes just putting this in the environment slot and getting some lights, even not too much of special lights. One light casts shadows. Don't have some fancy linear workflow things. For example, if I was rendering this with mentor array, it would be photometric and a bit more complicated. Here, quite straightforward. So some lights and turning on the motion blur here. No global animation in this case. I don't think it's really necessary. So then all that was left was to render, and as you see, I got this kind of result, which is really cool. The stuff works great, the motion blur works great, the environment works great. I think it's really cool. So eventually, what we're going to be talking about is how to get more interesting stuff in there, like blend this material with different material, for the faster stuff, for example, that you're going to want to be whiter, and then rendering all kinds of additional passes to help the compositing guys, because eventually what you output from the effects is passes that the compositing guys use, and you need to give them a lot of room to maneuver and shape color the whole thing correctly. And of course, the other thing which is very important in adding to the shading is the whole foam part, which is going to be something you're going to be rendering with Kakator. And yeah, with the next videos, it's just going to be going and become more and more interesting. And it would be really cool if this could encourage other people to upload their just experiments and findings with Naiad, because it's something that we all can learn a lot of, I think. Cool. See you guys next time.